Hi students, welcome to HSC Earth and Environmental Science and Module 7 Climate Science. This is video number 17. We're going to have a look at the interaction between human activity and ocean acidification. So the purpose of this video is to give you a bit of an introduction into the influence of human activities on ocean acidification. So one of the important things that we want to look at here is, I guess, to recap some things that we've looked at before. And one of the nice things about the way that the syllabus has been structured is that we do revisit some concepts more than once. And that means that we get a chance to reinforce what we learned the first time and hopefully extend on that understanding a little bit further. So hopefully now you have a little bit of an understanding of the relationship between carbon dioxide and water. So when carbon dioxide is added to water, it forms this weak acid known as carbonic acid. And we're familiar with that because it's the basis of soft drinks. So therefore, if we have an increase in the levels of carbon dioxide, it kind of makes sense that we might have an increase in the amount of acid. And therefore, that we might find that there's some relationship between increased carbon dioxide levels in the atmosphere and ocean acidification. So firstly, for example, we know that changes in the amount of precipitation can therefore alter the pH levels of particularly surface waters of the ocean and also any water bodies that might be occurring on the land. This includes rivers, streams, lakes, and so forth. One of the things that we have seen is oceanographers, like most other watchers of climate, noticing changes in pH of the world's oceans. And this has been tracked for probably about the last 200 years. We've seen small changes in the pH of the oceans, but specifically in the last 50 years or so, we've definitely seen some changes as a result of these increased carbon dioxide levels. And so the increased carbon dioxide levels in the atmosphere are creating an increase in the amount of carbon dioxide that's being taken up by the oceans. It's also affected by temperature. So there is a factor here around ocean warming. And so if there's a change in the temperature of the surface waters, then that can also change the amount of carbon dioxide that may be able to be absorbed or dissolved, if you prefer, into water. And then we also have some changing or mixing of the layers. So we've also talked about what happens as oceans circulate, what happens to the material that's in the deep, or under what circumstances it rises to the surface and creates those sorts of mixing events. What we have noticed is that since the Industrial Revolution, and you want to try and continue to mention this idea of the Industrial Revolution because it is the basis of a lot of these key areas that we need to look at in the syllabus. But in that last 200 and 300 years, we have noticed that there's been a significant increase in carbon dioxide levels. There's also been a change in the pH values, a drop in the pH values. And so one of the things that's important here for non-chemists is a fall in pH equals a rise in acidity. And really that's all you need to know at this stage. If you understand about hydrogen ions in solution, that's good. It probably makes your answer deeper and a little bit more chemically correct. But the important thing is there's a relationship between pH and acidity, where a lower pH means a higher acidity. Now, there's a number of different consequences associated with that, which we also need to have a little bit of a look at. So we know that oceans absorb about 30% of the carbon dioxide that's released into the atmosphere, and that the levels have been increasing. And they've been increasing for a number of reasons, one of which is the addition of material to the atmosphere, and the other is the decrease of living things that actually extract carbon dioxide from the atmosphere. There's also been an effect of change in temperature. So each of these combining together has meant that we've got higher levels of carbon dioxide that are being absorbed into the oceans. And higher carbon dioxide means higher concentration of hydrogen ions and a lower pH. So this is the relationship that I talked about before. So a lower pH means increase in acid, and that means an increase in hydrogen ions. Hydrogen ions aren't sort of too much of a problem for us to worry about ourselves, except for the fact that one of the important principles in chemistry is that we need to balance our ions out. So if we've got positive ions, we have to have negative ions somewhere. The negative ions are these bicarbonate or hydrogen carbonate ions. Now, one of the problems is that they form as a result of the breakdown of carbonates. And carbonates are a very important component of the minerals that are in a lot of the shells of different types of organisms, and also in corals. So one of the consequences of an increase in acid levels is that we actually get some of these organisms that are generally protected by shells losing their outer shells, or at least having a level of deterioration in the quality of the shells. Often things like calcium carbonate, which are usually the main material upon which these are constructed, they are more likely to dissolve in these higher acid warmer waters. There's probably a few things that we need to look at, some nice little data here and again, one of the things that we want to try and continue to emphasize to you is the importance of being able to extract information from data sets, from tables and from graphs. So here's a few things going on here, and what you'll notice, of course, is, and those of you who are geographers probably will be quite happy to see a lot of these types of graphs because you'll be familiar with them. So the thing that's key about these graphs is they often have two vertical axes, or two y-axes if you prefer. And so what we have to do is we have to look at the keys, or we have to look at the colors to try and get a sense of what's going on. So what does this graph tell us? Well, there's a graph of carbon dioxide in ppm, parts per million. And so you can see that there's a range of values for the air and also for the water, the seawater. And both of those are showing an uptrend. So we can actually see from the years 1980 to 2015, we've got a bit of an uptrend. Not huge, but significant and very recognizable. To go with that, at the same time, we have the black little squiggles, and they look like they're slightly going down, and that's a measure of pH. So the pH is actually slightly dropping. We've got a bit of a downturn going on there. And so is the CO3 So that's the carbonate ion. So remember I mentioned to you that one of the things that a lot of the shells of different organisms are made from are carbonates, like calcium carbonate. So the concentration of these ions we can see is coming down. And so that's going to also mean there's less carbonates available for the production of these little shells. So again, you can see a horizontal with a slight dip downwards. So we are seeing a little bit of a drop there. So when you're talking about sea changes, we're talking about oceans absorbing excess heat. So one of the things that's going to happen is we will get slight increases in temperature, especially at the surface. And perhaps further down if there's more mixing, but we'll definitely get some high temperatures on the surface. And this means that oceans will absorb excess carbon dioxide. And so the increase in the carbon dioxide levels is going to mean an increase in the acidity. And as we've said, this is going to lead to a decrease in the pH values. And so that changes the ocean chemistry. So we've got changing ocean chemistry in terms of carbonates. I'll put them down, carbonates, which is our CO3 ions. We've got a change in the number of hydrogen ions. So that's our H+ ions. And we've also got an increase in our bicarbonate ions as well, which is our HCO3- ions. Now, in addition to this is assuming that the only change that we have is the change in carbon dioxide. But we also know that in combination with the ocean circulation, we might find changes in salinity. And this capital delta here just means change. Hopefully you are familiar with that symbol now. So we've got changes in salinity which might be occurring. We've got changes in rates of deposition of carbonates in particular. And what this does is it leads us to a change in the ecology. So this affects the formation of things like corals, organisms with shells, and these can be macro and microorganisms. So it can include macro, like snails, oysters, and micro like foraminifera. And we looked at forams a little bit earlier in this particular unit. So there's lots of consequences in terms of changes of ocean acidification. But remember, we need to go back and we need to look at some data that's happened over the last couple of 100 years to see whether or not this influence from the Industrial Revolution has actually changed anything about our atmosphere, about our environment, that's led to changes in ocean acidity. So just a bit of an overview, and certainly something we'll have a little bit more of a look at in class. Thanks for watching.